Hello, everyone. I'm Damien, CTO here at SoftSmile, and we're delighted to welcome you to our webinar. So we're going to be talking about CBCT functionality that we added to our vision software. CBCT, also known as cone beam computed tomography, is an advanced imaging technique which is traditionally used to extract volumetric data of the mandible, of the maxilla, and all the bone structures, as well as the roots of the teeth. And roots is exactly what we're going to be focusing on. So while not all cases, in our experience, not all cases that come through our software have CBCT, we definitely see an increased popularity and an uptick in the frequency of cases with CBCT. We consider this to be due to general improvement in accessibility of the technology, as well as the general benefit of having lower exposure to harmful radiation. So apart from that, the general benefit is, of course, being able to see what the roots look like, the patient-specific, accurate geometries of roots increases confidence of the clinicians, of our users using the software, in the confidence in the accuracy of the clinical outcome of the treatment plan that they're generating. So with these benefits in mind, we decided to build that into Vision, and we're going to be showing you how it works, how it fits into our advanced arsenal of existing advanced features, which are specifically work together as a unit to essentially achieve the high accuracy and high level of clinical outcome for your treatment plans. So this being said, I would like to encourage you all to participate in the comment section to ask any questions that you may have during the demo. And now I am to pass initiative to our wonderful product specialist, Maria Caro. So she's going to be doing a demo of the aforementioned CBCT functionality, and we'll see exactly how it works and exactly how it fits into the other ecosystem of functionalities in the Vision software. Please, Maria.
Thank you, Damien, and hello, everyone. Thank you for attending today's session and taking the time to be here. Again, like Damien mentioned, my name is Maria Caro, and I will be presenting a case with a treatment plan that was shared by one of our founders, Dr. Islam Reslan, where he discusses how he uses CBCT integration in his practice. Now, you should be seeing the case momentarily on your screen. And we will touch base on why he selected to integrate CBCT for the treatment of this case, and follow with a walkthrough of the CBCT integration and where the CBCT files can be added when we create a new patient in Vision. Then we'll go through a step-by-step progress of the case in the pre-processing stages until we can see the visualization of the real roots render once the CBCT images have been processed. So one of the things that we'll go over is the real and parametrical roots that you can have the option to use, and we'll discuss that when we get to that moment. And again, once more, like Damien said, you have a comments tab on your screen that you'll be able to type in any of your questions, where our team behind the scenes will be gathering them for our Q&A. So I'm just gonna slowly turn and rotate the case so you can get a bit of a better visual of the buccal areas of the case. And in our discussion with Dr. Reslan Bekov, we asked, why did he select this case to use with CBCT analysis? What was complicated about this case? And his response was that in general, he uses CBCT in almost all cases where significant tooth movements are planned and where root parallelism is required due to any root anomalies, or in cases with impacted teeth. Now, the complexity of this case is that it's cosmetically demanding due to patient bruxism. He explained that the presence of CBCT allows him to ideally expose the torque and angulation of the roots. And in this case, because the anteriors and posteriors of the patient show wear facets, so you can see in the posterior areas, and as we go through the anteriors, where those facets are. The absence of the mesial incisal edge and the mesial edge of the central due to the central overlapping. Looking at the crown part, it's very difficult to assess the correct parameters of the torque and angulation. And as we look at the buccal areas, the patient has a class 2 on the left and a class 1 on the right. So I'm going to go ahead and activate the treatment plan that Dr. Rezanbekov provided. And I'm going to also remove the gum tissue so you can get a visualization of the real roots of this case. And as I scroll down the treatment plan, we can see where he used interproximal reduction. So I'm going to activate the areas where the interproximal reduction was executed so we can visualize how part of the treatment progressed. So the hexagons that you see with the values are where the execution of IPR or interproximal reduction was done. So I'm going to scroll down so you can get a visualization of how the treatment plan progressed. And I'll go through the individual arches as well, but we did want you to get an idea of how the case progresses, how he corrects the class 2, and how we can see the leveling and aligning of the lower anteriors. So we'll go through the occlusal of the case as well. So the doctor's treatment plan included the leveling and aligning of the dentition of the upper and lower arches and used the interproximal reduction, correcting the occlusal curve to resolve the cosmetic aspect of the case. And this is one way he uses CBCT integration in his practice. So what we'll follow with next is how we actually add CBCT into a new patient's case. So we'll go through that. So I'm going to minimize this, and we're going to create a brand new patient in VISION. We'll go ahead and enter the required information, patient's first name, last name. An automatic ID is created, and we can choose to enter the patient's birthday, or we can choose just to use the date of when we create the case in our system. The options with the red asterisks are the mandatory cells that have to be added with the information, and then the rest of the cells are not mandatory. We'll click next, and then we'll go into any notes that we can add to the case that may be seen throughout the case as we manipulate any of the items that we need. And then we'll go ahead and add our upper and lower STL files. So we'll click into the cell, select our upper, and select our lower. And while those are uploading, we can continue to look through and see if we're going to add any patient photos, whether they are profile photos, intraoral photos, x-rays or panoramic images. And at the very bottom, we'll have the option to upload the CBCT. So we'll simply click into the cell, browse for our zipped CBCT file, select it, and it begins to download. We'll go back up just to make sure that we have our upper and our lower STLs. And then as we wait for the images, remember CBCT images usually carry anywhere from 100 to 200 images. And once we see the image show up, we know that the files have been uploaded, and we would click on create. Once we click on create, we'll go ahead and go into the orientation of a model, where we place 3 landmarks on the occlusal surface, the incisal edge of our centrals, and then we'll do the same thing for our lowers. And this will create the orientation and plane of our upper and lower jaws. At any time, you can undo or create the steps again by placing the 3 bullets up on our upper arch and our lower arch. So if you made a mistake, we can always select this icon and redo the steps. Once we finish the orientation, we'll move forward. And we're going to move into our model corrections. So this is where we'll be able to make any corrections to the surface of the gum tissue or the tooth surface. So we can begin to use either the smoothing tools if we need to smooth any areas. We can use our remove if there are brackets that need to be removed, or if there's items on the tissue that we would like to remove. And we can patch them up by clicking on the patch options. And then we will simply click on the bullets to fill in the missing mesh. We can also use the extend to increase the mesh that may be missing in certain areas when the intraoral scan was done. Or we can continue to use the intrude buttons and continue our modifications on the surfaces. You also have your undo and redo buttons, so you can undo all the actions or redo the actions if you need to. We'll move to the next step. And now we're in the segmentation process. So we will be placing mesial and distal landmarks on every tooth to get this T mark over the occlusal surface. And if there are any teeth that we do not want to include in our charting, we simply go to the chart, select the tooth, and then you'll see an icon that says missing tooth on it. You can select it so that tooth is not included in the chart. We will do this for our upper and our lower. And then once that's completed, we'll be able to move to the next step. Now this is where the crown has been segmented from the tissue. We can go ahead and select a tooth on the chart if we wish to make any corrections, or we can simply click on the tooth segmented area and we can continue to add bullets or remove bullets to make any changes or modifications or corrections to the segmented tooth. And again, you still have your undo buttons that you can undo and redo any of the actions. And we're simply evaluating your buccal, lingual, and facial areas of both arches to make sure that the segmentation has been done correctly. Once we finish this, we'll move to the next step. Now, these are all pre-processing stages that we're going through before we can actually see the rendering of the roots. So this is where the software will begin to evaluate any artifacts or areas that show anomalies, and they will be discarded. And this is also where you'll be able to identify any black triangles that are in the interproximal areas or where gum tissue has recessed. We'll continue to the next step. So this is our baseline segmentation. This is the area where the software will automatically give you the 2 to 3 millimeters of gum tissue to be included on your models. You can go ahead and make any changes and manipulations by either changing the segmented line or going ahead and adding bullets to make additional changes. The software will automatically, like I said, give you that 2 to 3 millimeter mark all the way around. And if you want to make any changes, you can go ahead and do so. It'll do that for both the upper and the lower. And again, you still have your redo and undo buttons if you need to make any corrections. We'll move to the next step. And in this scene, you'll be able to see the 2 to 3 millimeters of gum tissue that has been included. And you'll also be able to think about your production of your models. We have a sealed and automatically sealed horseshoe base for both the upper and the lower. And if you choose to increase the height of the base, you can do so to both jaws by clicking on the box for both jaws and then simply using the slider to increase the height of the base of both arches. Or you can always just uncheck the box and choose to increase the height of one of the arches. Once you finalize this step, we can go to the next step. And here we have the rendering of the real roots. I'm going to remove the gum tissue. And as you can see, these are the real roots. Now, we talked about the option of having real roots and parametrical roots. So we have the option to include the real root that you can see here. And if we chose to use a parametrical root due to anomalies, like you possibly see here on this molar, we can either select the entire arch to have parametrical roots by going into the arch menu that you see here. It says real roots, and you can click and use parametrical roots. And as we click that, you'll be able to see the rendering of the parametrical root across the upper arch. Now, the parametrical roots are simulations of the root of the teeth with the ability to change axis. Now, because this is not the real root and not the real axis, you may see these collisions appear as red triangles, and you can see how the roots kind of touch and merge into each other. In parametrical roots, you do have the option to select the tooth and change the angulation of the root. Again, because these are simulations. The real root, and I'll go ahead and change the upper again to real roots, you will not be able to change the angulation of the real roots. So because it is rendering from analyzing the CBCT images and providing the true angle, you can also identify one of the teeth if you do not want to use the real root. You can select it, and then when you right-click onto that one tooth, you'll have the option for parametrical root, and you can see it automatically changes. Now, to go in depth a little bit further on how our software works, I'm going to let Damien talk about that.
Absolutely. Thank you, Maria. I think first thing that's very important to mention that this works, this is an AI-based algorithm. And it's not just AI, it's actually machine learning, neural network-based algorithm that sits there in the cloud and does all these segmentations. Just like with any other machine learning-based algorithms, they're all very hungry for input data, for something called training data. And training data is essentially just examples of real life segmentations done by humans. So someone needs to provide all that training data. So for this purpose, we had our clinical team, a number of experts just sit there and manually do all those segmentations, spend a lot of effort and time to essentially embed their expertise and knowledge of how to distinguish between root tissues, between the crown tissues, between the bone tissues, and the soft tissues surrounding the entire set of data in the scan. So once that's done, all of that input data, the training data, gets fed into the model, and model just sits there learning, and thus the word learning in the machine learning term. So with this done, once it takes a little while, and once that's done, we have a trained model. So this trained model gets deployed in the cloud. So the reason why I'm mentioning that it's deployed in the cloud is the fact that it's pertinent because the model is not sitting there on your PC and consuming your resources. So it's not. So we do not expect you to have a powerful PC to do all those segmentations. It's actually sitting somewhere on our server, is doing all that processing, and we're essentially offloading all that processing to our cloud instead of loading your computing machine. So once that's done, the segmentation produces just the geometries of the roots. But the next step, the next thing you need to do is you need to merge the segmented root onto the existing scan extracted segmented crown. Because generally the segmented scans will be intraoral scans, and the mole scans will have higher precision, higher resolution. Therefore, we want to preserve the crown with a higher precision and then attach and merge the root onto it. So this is also quite a complicated process. It also happens in the cloud, and most importantly, it happens without any effort on your behalf. So we don't expect our users to be involved in that process at all. Uh, and just like uh, Maria demonstrated, the only thing that our user is expected to do is go in the very beginning, upload the CBCT scan, and the rest of the process just happens in the background automatically. It happens fast, it happens accurately. Of course, there are situations when there are some kind of anomalies that may show up as part of the scan, and this directly depends on the quality of the original CBCT scan. So depending on the make and the model of the tomography device, you may have higher resolution, lower resolution. There may be some kind of low contrast areas. There may be some kind of fillings and implants. All of that has impact on the accuracy. So, and for that purpose, Maria demonstrated that you can always switch to the parametric route to avoid any kind of issues. And in general, I think it's important to emphasize we do not force using CBCT. If you don't want to use CBCTs, it is completely optional. You have the final decision. You make the final decision. If you have CBCT, you can build it in. You can completely do a full case from the very beginning to the end without involving CBCT whatsoever. And I think it's very important to comment that no manual effort, and the benefit is the fact that you have this additional information about the structure of the roots. No more guessing, so you don't need to guess for cases with more advanced, complicated cases with substantial tooth movement. You don't necessarily need to guess of how these roots would be interacting with each other and the surrounding bone. And these are the benefits that we bring in with this brand new functionality. So I think this more or less concludes our demo. I think Maria did a great job of demonstrating exactly how it works and how it fits into our existing arsenal of advanced features for treatment planning. So with this being said, I think we just progress to the Q&A section and try and answer any of the questions that you had. So just go with the first one. Can you redo it, please? Oh. Which format do you accept coming from the CBCT? Right. So, right. Which format do we accept? It's, of course, DICOM. So the industry standard DICOM format, it can be as either a single file, a zip file containing all of that information, or like a folder, just like Maria mentioned, like 100 or 200 or 300 files of these slices that the CBCT device produces. So these are the formats. Industry standard DICOM is the format that we support. Next question. Does it only accept hollow scans, or would a prepared solid model also be acceptable? So if we're talking about CBCT scans, we expect the original unmodified volumetric data. So as the CBCT scan, which is volumetric, so it's not hollow, it's essentially a 3D set of data, we expect it as is. So if you're referring to the scans, those would be either intraoral or mold scans, which would be the surface only. Right. Why use parametric routes when real is available? But firstly, real isn't always available. I think that's very important to emphasize. CBCT is not always warranted. It's not necessarily mandatory to do a case. In many cases, you're going to end up without any CBCT data, and you somehow still need to estimate what the routes look like. So our parametric routes are not just completely arbitrary. You must have noticed when Maria was demonstrating that they have appropriate shapes. They don't necessarily have the right directions, but the axis directions, I mean. But that's why we have this built-in functionality where you can make adjustments to the axis direction, and you can make sure that your parametric routes are also pretty close to the real thing. But of course, if you have the real thing, it's always preferable to do the CBCT segmentation and just use the patient-specific actual real routes. And that's probably the reason why we have both parametric and the CBCT. And also, as I mentioned, even if you have CBCT, there are things like fillers, there are things like implants, which interfere severely with the contrast of the CBCT. And there are sections, oftentimes there are sections of the CBCT which are completely unreadable. There's essentially no data in there. And if that occurs, the system will kind of fall back to the parametric route for the section which is unreadable. The rest will be fine, so the rest will be patient specific, but the section which is unreadable will be fallen back to parametric routes. So hopefully that answers the question. So is it possible to change the axis and center of resistance of a route with real route? I think Maria can comment here and correct me if I'm wrong, but I think it's quite possible. So center of resistance is predefined and it's based on the length of the route. So when you go to setup, I don't know if Maria showed it or not, but in the setup stage, when you're actually doing the alignment of teeth, when you're doing the treatment planning, you can pick different rotation pivots, right?
Correct.
The centers of rotation. And these pivots are based on the length of the route. And if your length of the route is from the CBCT, you will be using the accurate centers of resistance. Hope that answers the question. Oh, that's a brilliant question. For now, we only handle roots, but the bone is coming. So the next step, so we've currently focused on the roots only. And the upcoming release of this functionality, the next release, will also feature the mandible as well as the temporal mandibular joint to give you a much better idea of how, you know, bite jumps and articulators may work. So for now, that bone is not there. For now, it's coming. So how long does it take to process CBCT? First thing, I would like to reiterate, it doesn't involve any manual effort on your or ours, in fact. So no manual human labor is involved. So it's fully automatic, and it typically takes 2-3 minutes to do it in the cloud. So it's gonna sit there for a couple minutes to do the entire processing, and then do the merging. So do the segmentation, and as I described, merge them with the crowns, and then you can download it. So it's not long at all. Maria, please, jump in at any point.
You're doing such a great job. There's like no
Okay.
need. And
Yeah.
thank you.
I don't want to impose myself. I don't want to be the only
Not,
one.
not at all. You're absolutely answering everything perfectly.
All right. Does the software alert if overlaps between teeth during movement exceeds the IPR volume? Indeed, it does. Indeed, in fact it does. So there's a configuration where you can define what the threshold is. Typically, in our example, is 0. 0.9, so 900 microns. 0.9 is the maximum IPR. And then if the system sees that your IPR or the necessary IPR exceeds that threshold, the system is going to give you that red kind of box saying, hey, no, that exceeds the IPR value. And of course, this threshold is configurable, so you can change it to your protocol.
Yeah, and to add to that a little bit, it also continues to share with you the value of collision that you're creating as you're moving the teeth. So you'll see those values in real time as you move the teeth, and it collides with an opposing arch or with a tooth that's mesial or distal to it.
How do you merge CBCT DICOM files with scans STL? Do we need to convert DICOM into STL, or do you not? That's a very good question, and no, you do not. So we only expect you to do the segmentation that Maria showed. So you bring in the intraoral scan, you do the segmentation, and in the very beginning you also upload your DICOM data. And what the system does in the background, it just does something called registration. So it's a mathematical, geometric, advanced mathematical algorithm, which is specifically aimed at bringing two objects together so that they match, so that their shapes match. Of course, there's going to be quite a significant deviation from what the shape of the tooth of the crown looks in the CPCT and what it is in the scan. However, they're close enough to allow us to estimate and do the registration, bring the two scans together. And once they're together, we take the crown, we take the root, and we run, a few geometry processing algorithms to smoothly kind of build like a connecting surface between the two geometries. So to answer your question, no, you don't need to do anything. You do your regular scan segmentation, just like Maria showed you with the points, with the contours, which is also automatic, and you upload your CBCT scans into the cloud. The rest happens automatically. Do also support mixed dentition. Maria, maybe you can comment there.
Currently in our charting, we can have different charts or ways of identifying the teeth, but we currently do not support the children dentition and identifying those in the charting, but I'm sure it's coming.
It's coming very soon, indeed. Does the software give you the possible or preferable AI treatment based on a specific STL? Right. So this is something we call automatic setup, and this is a feature that's coming up pretty soon. So this would be also coming in a later release. Right now, we already have a hello.
Okay, yeah, you're
Yeah,
back.
sorry, I just touched the cable. So I think your question has to do with the setup rather than staging. But I would like to say still that we have automated staging, AI-based automatic staging. So once you manually do the setup, the alignment, the rest of the process of doing the staging and figuring out what the sequence is, what the speeds are, all of that is automatic. For now, the setup itself is manual in terms of just aligning the teeth to the final position. But resolving collisions, resolving spaces, closing gaps, doing the staging itself, sequencing, etc., all of that is automatic. Of course, in an upcoming release, we're going to have fully automatic setup as well as the rest of it. So, can instead of CBCT use PAN? I think PAN is
Panoramic, we do have the option to upload the JPEG of the panoramic, but that part is purely a visual
yeah,
for
correct. So
identification.
so you can use PAN as a reference, but the PAN is lacking the volume, right? It's lacking the volumetric information for us to extract the roots as like a 3D object. So, of course, you can use panoramic as a reference. So you can even pull it up in the setup as an image. So you can have your dentition, the 3D view on the right, and the panoramic scan on the left, and then use it as a reference. But the pan itself is just lacking the necessary 3D information for us to be able to extract anything out of it. I think, right, that's a very good question. The industry standard is more or less defined. So I wouldn't be able to give you actually name you the specific kind of settings, but the industry standard typical orthodontic settings for contrast, for the rest of it, for the resolution, etc., just works. And we have trained our algorithm on a wide variety of these settings and a wide variety of these makes and models of CBCT devices. So we expect to support a vast majority of them. Of course, there's going to be some outliers, and over time, as we maybe collect some feedback and we realize, oh, we actually, have an issue with a given make or model, we're going to improve the model.
And I believe that is the last of our questions.
All right.
Great.
I
Well,
Yeah, Maria,
yeah,
you're
just
gonna mention.
as a final thought, we just wanted to thank you. We were all very glad that you were able to join us today and learn more about vision and how we can help practitioners tailor treatment plans and improve patient diagnosis and outcomes. So please look at our comments tab. You'll see that our team is posting information for our YouTube channel with more educational videos, and we'll be following up with emails on next steps. So thank you so much again for attending. We appreciate it.
So, awesome, thank you. There's one question.
Oh,
Sorry,
one
there's
more
one more
question came
question.
up.
Yeah, just one more question. I'll
Okay.
just say that in a demo case, you have visualization of a whole third sector simultaneously. Do you have an automatic staging feature to make razor sequential? Indeed, we do. So it's not necessarily going to be razor sequential. It's going to use biomechanic and mathematical optimization techniques to do the sequencing. So it's going to avoid any collision. It's going to minimize the total treatment plan duration, and it's going to happen automatically at the click of a button. Uh, just like Maria mentioned, there are online YouTube videos of how this functionality works. So this webinar isn't really focused on staging. So I don't think we're going to demonstrate that, but there is a lot of additional, yeah. So there's the YouTube channel where you can see all of that at work. Awesome. So I think we're going to sign off now. Thank you very much. Please follow the links, and we're going to be in touch. Thanks a lot.
Thank you.
Cheers.